Alright guys, today we're going to be dealing with complex numbers or imaginary numbers. Okay, so here's the thing. This is the biggest thing. See how it says I form? What we need to remember is that the square root of -1 is equal to I. Because if we entered square root of -36 into our calculator, it would tell you error. So remember what we can do is we can change this to square root of -1 times square root of 36. Well, square root of -1 is I, square root of 36 is 6, so the final answer is 6I. Okay, so this one, again, you can go -1, 49, and then it would be 7I. So just remember, when you see the negative and they're talking about complex numbers, it means treat it like it's positive, but you add that I in there, okay? So here, what's the square root of 16? 4. Square root of 25, 5, but because it's negative, it's imaginary, and it's I, okay? Now here, since they're both underneath the square root, you can treat it like this, but that's just 16, so it's 4. There's no I, because what's a negative divided by negative? A positive. Okay? Alright, now here is a key that we need to remember and recall. Okay, so let's look. I to the first is just I. I squared is -1 because you have well, no, it's just I times I is I squared, so it's -1. Okay? Because if you think about this, we have square root of -1 times square root of -1. The square roots go away, so it's -1. Okay? Now, I to the third is I times I squared, which is -1 times I, so it's -I. I to the fourth, I squared times I squared, which is -1 times -1, which is 1. Now notice how they start repeating after that. So you need to make sure that you realize and recognize these four, because everything after that's a repeat. Okay? So let's see how we're going to use these. Alright, so it says perform the indicated operation and write the answer in standard form. Okay? Now standard form is A plus BI. It's the real number plus the imaginary number. Okay? Alright. So the square root of -16 is 4I. The square root of -36 is 6I. 4I plus 6I is 10I. After you get it to be the imaginary complex number, just treat it like it's a variable. Don't freak out about it, okay? So let's take a look at another one here. So now we have negative square root 48 plus negative square root 12. So you can't just add them together, but what we need to do is simplify each of these. So I know that I can make this 16 and -3, and I can make this 4 and -3. So this is going to be 4I times the square root of 3 plus 2I times the square root of 3. Again, the square root of -3 becomes I square root of 3, square root of 16 is 4. Square root of -3 is I square root of 3, square root of 4 is 2. Now what's 4I plus 2I, because they both have the square root of 3, so you have 6I square root of 3's. That's also sometimes written as this, but I prefer this way. So talk with your teacher, make sure you figure out what they prefer. Okay? So now we have this one. So first thing we got to do is simplify. Well, we already did the first two, so we know this is going to be 4I square root of 3, and this is going to be 2I square root of 3. Now this one I can say minus, and we could change that into square root of 9 times square root of -3. So you have 6I square root of 3 minus 3I square root of 3. 6 minus 3 is 3, so you have 3I square root of 3's. Okay, so let's take a look at the next. Alright, this one looks nice, so it's times, it's multiplying. So here we have 5I, and then this is I square root 6. We can't simplify the square root of 6 at all, but you do have to pull out the negative and change it to I. So then this would be 5I squared root 6 But I squared is -1, so it's 5 times -1 times the square root of 6. So it's -5 square root 6. Okay? So there we go. Alright, let's look at this. So here, this is going to be I times the square root of 5, 4I. Can't simplify that at all, minus I square root of 10. So can't simplify the 10, but you can make the I. Now distribute. So you have 4I squared times the square root of 5. Distribute. You have minus I squared times the square root of 50. That is not the answer. So now we have 4 times -1 times the square root of 5 minus -1 times the square root of 25 times the square root of 2, because I'm simplifying my square root 50. So I get -4 square root 5 plus 5 square root 2. Okay, and the reason this is a plus is negative times a negative is positive, and then 1 times the square root of 25 is 5. Okay, you can't add those together, so we're all set. Let's take a look at another one here. Okay, here, -16 square root, it's just -16. It doesn't make it positive because all the square does is get rid of the square root. Let's take a look at a couple more. Alright, so see, here we have two different complex numbers. What you want to do is just treat it like it's an equation, combine like terms. So what's 4 plus 6? 10. What's -3i plus 7i? Positive 4i. Write it this way. This is where it's a little different. Normally we're like used to saying 4x plus 10, but when it's the imaginary numbers, standard form, a plus bi. Okay? So here, now this one, we got to be careful. Over there I didn't bother because it was positive, but here what we need to do is distribute the negative first. So you have 30 minus I minus 18 minus 6i plus 3, and remember I squared is -1. So I have 30 minus 18, 12, -I minus 6i, -7i, and then minus 3, so this would be 9 minus 7i. Alright, let's keep going. Alright, so here, before I distribute, I'm going to simplify this. So it's going to be 9 minus 2i times 2i. Distribute, so I have 18i minus 4i squared, which is 18i minus 4 times -1. So that's 18i plus 4, so I should write this as 4 plus 18i. Because remember, standard form of a complex number, a plus bi. Okay? Let's take a look at another one here. So here's the thing. Imaginary numbers, complex numbers, should not be in the denominator. So what you need to do is, it's called the complex conjugate. So the rule for complex conjugate is a plus bi. See how it says plus? So it'd be a minus bi. That's what you have to multiply by. Those are conjugates of each other. So I will multiply the top and bottom by 5 minus I, 5 minus I. Okay, so distribute out the top, so you get 25 minus 5i minus 5i plus I squared. The bottom, 25 minus 5i plus 5i minus I squared. So if we combine like terms, the top you're going to have 25 minus 10i minus 1, because remember I squared is negative 1. So those are gone. Now do the bottom here. You have 25. Well, negative 5i plus 5i is 0, and then I squared, remember, is negative 1, so it's going to change to plus 1. So you have 24 minus 10i over 26. Now we're close, but we still need to do a little bit more. So I need to go 24 over 26 minus 10i over 26. Simplify, so you get 12 over 13 minus 5i over 13. That should be your final answer. Okay. Let's take a look at some more. All right, it says determine if complex numbers are equal. So it wants to know, does this equal this? Well, what's the square root of 1? 1. What's the square root of negative 25? 5i. So yes, they are. Here, they want to know, determine the values a and b that satisfy the equation. So here's the only mistake that's made in these notes here. This should say 2a plus. Okay. So there's the one mistake. So let's back up here though. It says 3 minus 4i equals a plus bi. So we know a equals 3. We know negative 4i equals the bi. Divide by the I, you get b equals negative 4. So there are the ones that you need to equal. So if we look at that over here, we have negative 10 equals 2a. Divide by 2, you get a equals negative 5. Here you have 5b minus 3 equaled 12. I left the I off because remember over here we could just divide by I and they cancel. So they're going to cancel again. So add the 3. Divide by 5. So you get b equals 3. So our answers to make these real, a is negative 5, b is 3. Alright, we'll see you guys in class.